Mastering big data processing. Eliminate a single misstep, salvage your entire operation. How can our operations team identify and mitigate single points of failure in their processing pipeline to ensure continuous data processing and minimize the risk of service disruptions? To identify and mitigate single points of failure in the processing pipeline, the operations team can follow a structured approach that involves monitoring, analysis, and remediation. Here's a detailed solution. Monitoring. 1. Implement real-time monitoring tools. Utilize monitoring tools such as Nagios, Prometheus, or Datadog to monitor the entire processing pipeline in real time. These tools can provide insights into system performance, node health, and data flow. 2. Set up alerts and notifications. Configure alerts and notifications for critical components and nodes in the pipeline. This ensures that the operations team is informed immediately when a node or component fails or becomes unresponsive. 3. Collect and analyze logs. Collect logs from each node and component in the pipeline, and analyze them using log analytics tools such as ELK-Stack, Splunk, or Sumo Logic. This helps identify patterns, anomalies, and potential issues. Analysis. 1. Conduct regular pipeline audits. Perform regular audits of the processing pipeline to identify single points of failure. This involves reviewing the architecture, node configurations, and data flows to identify potential bottlenecks and vulnerabilities. 2. Analyze system dependencies. Identify dependencies between nodes and components in the pipeline. This helps identify which components are critical to the overall functioning of the pipeline. 3. Determine mean time to detect, MTTD, and mean time to resolve, MTTR. Calculate the MTTD and MTTR for each node and component in the pipeline. This helps identify areas where improvements are needed to reduce downtime. Remediation. 1. Eliminate single points of failure. Implement redundancy and load balancing for critical components and nodes in the pipeline. This ensures that if one node fails, others can take over its responsibilities. 2. Implement automated failover. Configure automated failover mechanisms to switch to standby nodes or components in the event of a failure. 3. Develop backup and recovery strategies. Develop and regularly test backup and recovery strategies for critical data and systems. 4. Implement quality of service (QoS) policies. Implement QoS policies to prioritize critical data flows and ensure that they receive sufficient resources. 5. Train personnel and develop playbooks. Train operations personnel on failure scenarios and develop playbooks for incident response. This ensures that they can respond quickly and effectively in the event of a failure. 6. Conduct regular disaster recovery drills. Conduct regular disaster recovery drills to test the pipeline's resilience and identify areas for improvement. 7. Continuously review and refine. Continuously review and refine the monitoring, analysis, and remediation processes to ensure they remain effective and up-to-date. Additional best practices. 1. Design for fault tolerance. Design the processing pipeline with fault tolerance in mind, using designs such as master-slave, peer-to-peer, or distributed architectures. 2. Use cloud-based services. Consider using cloud-based services that provide built-in redundancy, scalability, and reliability, such as AWS Lambda or Google Cloud Dataflow. 3. Implement change management. Implement a change management process to ensure that changes to the pipeline are thoroughly tested and reviewed before deployment. 4. Maintain accurate documentation. Maintain accurate and up-to-date documentation of the pipeline architecture, node configurations, and data flows. By following this structured approach, the operations team can identify and mitigate single points of failure in the processing pipeline, ensuring continuous data processing and minimizing the risk of service disruptions.